So today we are going to move on to section 8.4, and I believe, we skipped 8.3, so no 8.3 section. So we're going on to section 8.4, and in 8.4 we have vectors. So a vector is an object that has both length and direction, and so that's really important to what we have for vectors. They're going to kind of just really look like a line on a Cartesian coordinate plane, but it's a lot more than just a line. We're going to be able to tell a lot of things from vectors. They do have a length and they have a direction. So geometrically, a vector can be represented by an arrow that has a length and indicates a direction. If starting at the point A vector, which means carrier in Latin, moves toward point B, we write AB to represent the vector. So that would mean that we're starting at point A, we're going to move towards point B. So this is vector AB, and notice we only have one arrow on that line. Okay, a vector may also be indicated using a single letter in boldface type, such as U. Kind of like we could say line L is just lowercase l. We do the same thing with a vector, except for it would be bold type and U. Or by capping the letter representing the vector with an arrow, so we could also call it U. Now, because we can't really write bold type so that it's obvious, we usually, when we refer to just one letter of name of the vector, we'll just use the arrow above. Okay. All right, let's move on to example number 1. All right, for example number 1, find a vector that represents the movement from point P, -1, 2, to the point Q, 3, 3. And all they want is just the physical image of this one right here. So we've got the point P, -1, 2. Oh my goodness. All these reminders today. So the point -1, 2. And we're moving to the point 3, 3. And so we've got this vector here. And we could call that vector PQ. Okay, to add vectors geometrically, so that just means looking at the actual pictures of them. If we wanted to look at vector U plus vector V, then we would slide U, since this is the beginning place, we would start at the beginning, and we're going to draw a straight line to the end of vector V. So kind of like, if you've ever heard of this saying, as the crow flies, that's what the vector is. Okay, so go at a straight shot from the beginning to the end. Okay, example number 2. Given the two vectors shown below, draw U and V. Okay, I'm going to have to slide that up. All right, so now we can see U and V. So U is going to be our starting point, so we want to anchor that spot right there. That spot's not going anywhere because it's our starting point. So anchor that spot, and then what we're going to do is we want to slide this vector so that the beginning of this vector touches the end of U. We have to make sure that we have the same direction as V, and it also has to have the same length. Okay, so once we put that up there, now we can go ahead and draw in our new vector, which is the sum. So remember, the sum of them, when we add them, it's just like as the crow flies, start at the beginning and make a straight shot and have the same ending point. And so my red arrow here is vector U plus vector V. And that's how we would show a drawing of how we add vectors. Okay, then going back down here, we've got magnitude and direction. So a vector is really much more than just a line, because a vector can be described as its magnitude or its length, and really you can kind of think of it as a vector is a line with weight to it. And that's what we call its magnitude or its length. And we're going to denote that with lines beside, kind of like absolute value bars on each side of our vector name. Okay, so that means magnitude. And we also can describe it as an angle theta. So this should look very familiar to you. Yes, we are still going to be using all of the same types of equations and information as we have been using in Chapter 8. Length, we are going to call length r, so that should also look familiar to you. And we will be using those same equations to find that length and that angle theta. If a vector has a length of 1, it is called a unit vector. We will also learn how to make a vector a unit vector if we need to. Okay, we can also have a component form, what we call a component form of a vector. And a component form is going to be really the point that it ends on in the Cartesian plane is what it is. So it would say that this vector here starts at the origin, and then we would describe it by the point that it ends at, in this case, x, y. So we go over x units, up y units, and then the component form, I need those to be, sorry, those need to be pointy arrow. Yeah, like that. Okay, so that's how we denote that it is a vector, is by not using parentheses, but kind of an angled parenthesis. Okay, and that is what we call the component form of a vector. So these are the rules for combining vectors in component form. So we can add vectors, we can subtract them, or we can scale vectors. Scaling is really just multiplying. So if we want to add two vectors together, we're just going to take the first two terms, add them, take the second two terms, and add them. So just exactly how you would think. Subtracting, same way. Just subtract the first two terms, subtract the second two terms. And then when we're scaling, again, same thing, just multiply by whatever factor c to both of the values inside of the component form. Okay, for this first example, we are going to assume that this is starting right here at the origin. Okay, so let's say that's the point 0, 0. So the component form of this is going to be our horizontal motion. So 1, 2, 3, 4. So it's going to go to the left 4 or negative 4, and then up 1. So that's all we have to do to find the component form for a given graphed vector, as long as it's starting at the origin.